All right. All right. Good afternoon, everybody. This is quiet, boring, Mr. Samuelis. All right. Okay, you can read. Go ahead and do that. I am going to interject, I guess. These were the notes from Friday that, you could read. And actually, from reading the notes, figured out, you're going to college, most of you, right? You have to learn that way a majority of the ways. You want to be successful, it is going to have to be what you need to do. I'm not just being a jerk. It's the truth. So we did a silly little example. Remember the first day of this Monday and then Tuesday I said, all right, try to get in the mindset of we're trying to identify a concept with these Mickey Mouse examples. They do seem silly to task out cooking. Well, first we dressed ourselves, right? But then we're, tasking out making lasagna. Thank you. The brain got stuck on a Monday after a long week of being off. All right, happens. And then we talked about sources and sinks. What's a source? Starting point or end point? I don't have the time for this. Starting. What's a sink then? Silly terms from this section. So when we looked at this list, we try to prioritize who's related to who has a precedence relationship compared to the others, who are their separate sources that are not. So when we looked at this, we had to make a graph. That's what we did. Then we made a digraph with those precedence relationships analyzed. And then we made it weighted, the weighting just being the minutes it takes for us to do this. So this is just a reiteration of what you saw from the notes that were listed Friday. Tuesday, sorry. Weird week last week. And then we went ahead and did this. We tried to get the critical time. That's what I was trying to think. These terms are a little fuzzy in my brain after a long week off as well. Going from each source to sink, all right, and the critical time is the longest from the source to the sink. Because the idea behind that is this is the possible smallest time that this could happen. It could be no smaller than this. So this at least will take 83 minutes. But then we said, if I only had one processor, how long would it take for one processor to cook the lasagna? Now the idea is, if you have one processor, they can only do one thing at a time. Now I know realistically that's not necessarily the case. Of course, how many people do this if you're cooking? You brown the meat, but then you get that started, then you do something else. Then you go back and you burnt the meat because you didn't pay attention. I do that all the time. Cooking breakfast has a lot of things going on, and mess up the toast or the eggs get overdone, blah, 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 blah. So you want to do one thing at a time. So the question was, how long would it take for just one processor to do this? And the answer was not 83 minutes. That's if you get a couple processors working on a couple things at a time. Then maybe you could get it done in 83 minutes. If just one person, it's the sum of all these times. Well, that's what we're going to talk about today. When we add a processor, how could this be shortened? But again, you're stuck with it could be no shorter. It could only be equal to whatever the critical time is. Realistically, when cooking, is that necessarily the case? You can make some arguments. So, a couple ways of possibly doing this is making a priority list. And you can either go increasing time priority list, where you go from shortest to longest completion time, or decreasing priority list, longest to shortest. But there is a problem. There's also precedence relations. So you have to keep those in mind, because obviously if task 4 can't be done without doing task 3 first, you can't do task 4 first. So you have to also keep those in mind. That's what's happening in this little thing, this little shindig we're going to set up here. Wow, okay, so a redonkulous situation. Task 1, 2, 3, 4, 5, take these minutes. Real Mickey Mouse. Increasing priority list, you list them in order from shortest time to longest. Decreasing is the opposite. Answers to the right. Mickey Mouse. All right, let's move on to the next part. I'll answer that in a moment. Okay, go ahead and write this down. I'll put my little diatribe on it. Okay, what are you looking at here? A bunch of shoved notes in your face. Let me go back up here. Okay, and then hopefully you're not ahead of like what this is. So it's a Gantt chart. It's a diagram. Kind of got to look at it there when I showed a little too many notes there. That keeps track of the order of which tasks are done and how much time elapses them. And then this is not the Gantt chart. This is just a digraph. So what I'm pointing at right here, this right here is a digraph. We're going to make a Gantt chart off of it. And then this is just with one processor. So this is just Mickey Mouse. Mickey Mouse, this is how I create a Gantt chart with one processor, which means one person doing this. Now they just decide to say, do it as a decreasing time priority list. Okay, now this is kind of silly. I really don't think this is a big deal right here. Because you're stuck when you look at this digraph. Like, who has to be done first? Who is a source? T1 or T2? Who's a sink? T5. So T5 has to be done last. It has to be. We have to get all these other tasks done. They're all reliant. And that's the only purpose of talking about the lasagna. You know, you have to shove the lasagna in the oven. You just take all the ingredients and just, hey, open up the oven and just throw it all in there? Is that what you do? No. Okay, you got to get in order, get it all layered, and then you shove it in the oven. Okay, so even though I do a decreasing priority list, you know, putting T2, where's T1? Sorry, lost T1. I'm sorry, decreasing means highest time. I already screwed up. T1, 30. Then the next one is T5. Then the next one is T3. Then the next one's T4 and then T2. You can't do these in this order. So I really don't find much significance to this list for what you're going to have to do with it. And we'll talk about that when we put two processors together. So I'll probably cross this out when we're looking at this. It's just a way to keep track of things. I think you can keep track of it here. By the way, those that missed Tuesday, all we did was put weights on our little digraphs. So we put the minutes involved to do these tasks in a little circle, and then we did this this listing. Okay, and then here's what we got to understand. Who do we have to do first? Either T1 or T2. So our ready tasks are only T1 and T2 listed above here. All right, T1 and T2. All right. Then we can move on to T4, 3, and 5. So to write this down as with one processor, decreasing time, I picked T1 first out of T2 because it's the highest one. Now again, this is a stupid example just to exercise the idea of doing a decreasing time scenario. Right? When I have choices, I pick the highest time first, but then I have to understand that there's precedence relationships. I can't do T5 seconds. It's like putting the lasagna in before you got the meat ready or the cheese or the, so now the next thing is I put T2 next because it has to be done in that order. And then I'm stuck with T4, 3, and 5. So it's not really a great example. Wait till we get to the two processors and then, follow that order. And then some things are going to look a little bit better. Not great, but again, we're establishing an idea. So not a lot of specialness here. What you might want to do, I don't know how you're going to do this. If you have an idea like how long this is going to take total, put a little bar above this. And I'll show this when we have the two processors. I'll put it like in between the two, even though the notes are already finished kind of idea, so that you have a scale. So if you know this is going to take like the critical time or a little bit bigger than the critical time, the total time, it's going to be up to 100 minutes. I do a bar that shows 100, then cut that in half, make that 50. Cut that in half, 25, so on and so forth. So then there's a scale to do these little times that should represent that scale or that space. So T1 takes 30 minutes. We got to make that look like 30 minutes on our scale. Then we do T2 next, which is only, got to look at it real quick, 5. In relation to T1, that should look like 5 compared to 30. Does anybody know what I'm talking about? Okay. Yeah? Out of practice with the button. For multiple processors. Are you all right? I'm sorry for that if that upset you. Oh, we're on. This is silly. And again, come on. This means that, okay, we're going to cook lasagna, and I'm going to have my girls help me out. So it's me, and there's 4 processors. But one of them is stuck cleaning the room because Mom yelled at her. So one of the processors is not idle. They have to clean the room before they can do. All right, but none of that's happening. So obviously all the processors that are given are ready, and there's at least one task ready to be done. So this is kind of silliness to have to actually write this. Okay, but this is what your steps are going to be when we give you a list like we gave you on Tuesday. You know, the list of things to be done. Construct your weighted digraph. The smartest thing is to identify all sources and sinks. And then who has precedence relationships, meaning who's connected is the best way I can think about it. Step 2 is find the critical path and time. We know how to do that. We go from every source to every sink, or usually just one sink, and then get those times, and then figure out which one is the largest. And then remember what that means. The largest time is the critical time because that is the best we could possibly do. We can do no better than whatever the critical time is. Create your priority list. That depends if we go increasing or decreasing. I'm not really sure that's necessary. We can kind of look at our digraph in order to figure out what as long as we put it as weighted, of course, which I do have in there. And then assign the processors. Now this is where it gets real crazy in the book. I think we could do a little bit, circumvent the process a little bit, not make it too confusing. And then I think this doesn't really need to be written too much, but what's going to happen is we're going to assign these processors some tasks, and then once one task is complete, can we start another one? So when a task is completed, check for ready tasks and assign. If there are ready tasks, go ahead and assign it. Repeat step 4. If there's no tasks ready, meaning someone's working on a task and it has to be done before another one can start, someone's going to be idle, sitting there doing nothing, twiddling their thumbs. Remember that the finishing time could only be equal to the critical time or greater. And that should make sense after what we talked about Tuesday. If the finishing time equals the critical time, well, that's just fantabulous. That means with these two processors together, they got this done optimally. They did this in what could be no faster. She sneezed just like me. That scared me. Annoying. All right. You okay over there? You all right? What's the matter? Did you get that in the notes? All right. Oh, it's frozen. Let it go. Let it go. I'm starting to feel better. More Samuel stuff going. You don't have to write anything if you don't want. But if you want to do well, you probably should. Don't make me come out there. Oh, that's just... Here, let me get this for you. You're welcome. I'm here for everyone. Put that on Twitter. I need some positives. All right. So this is the ridiculous that we did stuff Friday. Not Friday. Tuesday. Actually, it was Tuesday. Sorry. That was correct. When we did the lasagna. What is this now? Pizza. Oh, man. Anyone ever have Jack's Pizza? I shouldn't put that online because that's like advertisement. Anyone? Frozen pizza? Oh. But you got to jack them up. I call them jacked up Jack's Pizzas. Like you add your own cheese, add any other elements. Oh man, it's great. Anyway, let's move on. Okay, so looking at pizza, I have a hard time focusing. So go ahead and write that down, and then we'll talk about what you need to do as a student. That's you. You, Mr. Samuelus, of my pain. You get it? Source of pain. I get these all jokes. All right, so who's the source? T1. Nice. Source, T1. Sure. That's its own little source. It has nothing to do with anything else. We could do that first. I mean, it's not connected to anything. There's also some others. T who? T2. Then I think T3. Oh boy. Uh-oh, there's a picture. There's a picture there. Sorry. That's my family online. What? What's going on here? All right. Now, is add sauce a source? So here's space. I'm going to add the sauce now. Psh, all right. It's going to be on the floor. All right. And then what's a sink? There's only one. Okay. So just so you know where this starts and ends, actually gives you some focus on how we're actually supposed to do our digraph. Now, I guess you could make some arguments about maybe a couple of these orders. So, you know, when you add something like, who likes their pepperoni underneath the cheese, so the cheese bakes on top of the pepper? It's a serious question. You don't have to shake your head. Some people have preferences. Raise your hand. How many people like the pepperoni under the cheese? How many people like the pepperoni on top so you get to really see it? See, again, this has every relationship to what you would put up. Oh, now they're all... Okay, it was actually a serious question. All right, so here's the... I should have had you do this, but I didn't. So here we go. Make and roll the dough. Probably have to do that first. Or we could do the grating of the cheese first. Or we could have done the T3 slicing of the pepperoni first. Or we could have turned on the oven. Okay, then this is the seriousness of my question. You would make and roll the dough. And then you do T4, probably add the sauce on there. I think all of us would probably agree that you'd have the sauce first, then the ingredients on top of the sauce. So that's why this would be the order of stuff. Now here's where the argument comes into play. What would you rather have? I think most people would... Well, this is weird. I think I would have switched this. Added the cheese after you grated it, and then added the pepperoni after you sliced it. These two might be switched depending on how you like your pizza. That was the whole point of my diatribe there. Okay, we're really getting into the pizza thing here. Okay, now, every source to sink. Every source to sink. Shh. T1 goes to what then next? T1? 4, keep going. 5, 6, 8, or 6, 5, 8. All right, what's another source to sink? 2, 5, 6, 8. Next one. 3, 6, 8, 7, 8. Okay, then of course probably the one with the longest list has the longest time. Not necessarily, but in this case it does. Okay, so as you're taking us down, we will finish the notes. Probably a little too much pizza talk, but I do like food. It is fun. The critical time is the longest of these. And it is the minimum that this task could get done. It could get done no faster than 64 minutes. That's the idea. Okay, because each task in that list has a set amount of time that cannot be changed, no matter that individual task is worked on by more than one person. Of course, you could have arguments for that. If you had two different separate cheeses that two people were grating, then you could cut that time a little bit. That's not happening, all right? So we're not doing that. These tasks are all individual. They're stuck. It will take 10 minutes, no matter what, to make and roll the dough. Adding 5 people to doing that instead of one wouldn't change that in theory of what we're doing. I hope you get that. So the minimum this could take is 64 minutes. It'll take 64 minutes or more. All right. Now, I did tell you that there are some things, and I'll hold off for a second. How many processors do we have, just so you know what that term means? Oh, no. And there's two. Who are the processors? Jennifer and Mark. The processors are the workers. All right, here we go. All right. So what we're going to do next is, I don't want to show the answer yet. This is what I feel like in green, I shouldn't even reveal this. I don't really think it has a lot of use. We're going to do an increasing priority list from this. But really, I think what we can do is not really necessarily write these in order, because it implies maybe to a student that they could be done in order when they can't. You can't just shove the pizza in the oven if T8 was the smallest time, even though it isn't. So an increasing priority list is what we're going to try on this. That means we're going to try to assign the tasks from smallest time all the way up to largest time. But we have a problem. We have to make sure we keep the order of things intact that we legally, there's that word again, have to do to get this pizza constructed before it's shoved in the oven. All right. Probably not going to do a great job of this because I have the graph already written out. But this is where I think you should put a scale down. So how many minutes could it be done minimally? What was the minutes? 63, 64. Wasn't it 63, I thought? 64, sorry. I got it cut off in the notes. What I think you should do, it could be more than that. So I think you might want to make a bar that, where you're going to assign these tasks, and there's going to be a person above and below that bar. So I think you should make a bar. It's going to be bigger than this. Maybe from 0 to 100. We hope we get this done before 100 minutes. So what you could do is add all the tasks. That would be the maximum. So if you added all these minutes, remember what I said, if it was only one processor, it'd be the sum of all these minutes, right? So it could be anything from the critical time to just adding all the minutes together if I had one person. And then, start barring this out, so that you have a relationship. That's 50, that's 25, maybe go by, tens or something like that. Your call. What this needs to do, though, is look good. It needs to look relative. Like if one task takes 30 minutes and another one takes 20, those bars should relatively look like that. And I think you better understand that from the first example that I showed you. Whatever you need to do. Okay, so here's our ready tasks. We have 4 sources. So we could start at any of those 4 sources that we want. I have 2 people that I can assign these tasks. So that's what we're going to do, and we're going to do it in the increasing method from the smallest task to the largest, but also keeping in mind that we have priorities here. We have some things that have precedence relation to others. Okay, with that being said, I'm going to zoom in on this and then start revealing what we have to do. Okay, let's just call, is it Jennifer and Mark? I forgot. Let's call Jennifer first. What should she do first if we're going increasing priority list? T7, the 1 minute one. She's going to get that. So that's what Jennifer's going to get. So then what should I assign to Mark? T2. And that's how we start. As Jennifer is going to start the oven, Mark is going to do whatever T2 is. It might be helpful to look at your own notes. I'm going to lose which one's which because I don't have them memorized. And then, so Jennifer's going to be done in 1 minute. Does she have to wait for Mark to finish his 5-minute task? No, because then after that 1 minute's done, she could do any of these 2. So she's going to start this one while Mark's finishing this one. Then we'll show you how this bar graph all looks out. Okay, then I'll explain it further as we go from here. Okay, so I'm just going off of this, not even this thing. I'm not even crossing these off. I don't think this is necessary. This is just a listing of tasks in order from the smallest minutes to the largest. I think the meaning is in here. I think this is what makes most sense. And you get that you can't start a task that has a precedence relation, not completed. So just like I said, Jennifer starts task 1. Again, this needs to look like 1 minute compared to Mark's T2, which takes 5 minutes. So Jennifer's working this 1 minute as Mark is working this 5-minute task. But Jennifer's done with this 1 minute task. And I do want you to watch this. I will give you time to write this down. So Jennifer doesn't have to sit here and wait for Mark because there's 2 other sources. There's 2 other things that can get started. So the next thing she's going to start is she's going to start the T3 task. And I think going in the graph itself, looking at this way, makes this a lot easier than worrying about ready tasks and that list here. I think these things are not necessarily needed. So she starts, but now she has to work what? How many minutes is T1? Did I put T1 there? Where's did I? Oh, she started T. Why did I do that? Hold on, I gotta check what I just did here. Did I make a mistake? I thought this was Jennifer and this was Mark. Jennifer starts T3. Now she's working. Now think about it. She did a 1 minute, then an 8 minute, which is 9 minutes. He finishes his 5-minute task, right? And she's still working. So now he has to start the T1 task because it's allowed. One thing you might argue is T7's done. Well, now T8's ready. Well, you can't argue that because what's T8? The shoving everything in the oven. Not everything's done. You know, and then this is not done yet, so none of these can be started because we haven't finished this one yet, and then this one, and then blah, 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 blah. We got to get the dough first, then the sauce, before we can do T5 and T6. So, Mark has to start T1. Now he's not done with T1. The dough is not ready. So this takes 5 and then 10 more minutes, 15 minutes. Jennifer's done in 9 minutes. She's got to wait until the dough's done before we can put on the sauce and then go from there. So this one doesn't show a real great thing because there is a little bit of idle time. And then once we're done with this, all the rest has precedence relation. So only one person can really work on it. I can't do T4 before I do T5. Can't do T6 before I do T5. Can't do T8 before I get all of them done. So at this point, we assign this whoever is left over. I guess we'll give it to Jennifer. It could have been Mark as well, but Mark just got done working. You know, so he's tired, so Jennifer takes over. She had a little rest. Okay, when you actually do this, there is some idle time. How many minutes of idle time? Very easy. Look at the idle time in there. How long is Jennifer sitting there doing nothing? Rooting on Mark. Come on, Mark. 6 minutes. It's simple if you put it in a graph and label the points. All right? And then when you add it up, you end up getting 69 minutes. So it wasn't the critical time. Wasn't too bad. If you add up all the minutes together, then you can see how much time was saved with 2 processors. I guess you could do that on your own. So what you call this is not necessarily an optimal schedule. An optimal schedule may not even be possible. Probably not in this scenario. If you look at this in any different way, depending on the precedence relations that are out there. So again, I think just looking at the digraph and then assigning the sources in a way that this case they said increasing, so from smallest minutes to largest, still keeping the precedence relationships intact though, because obviously that's how the pizza has to get constructed before it can get baked. All right. I know it's weird, but it is what it is. I'm done. Quiz time.